Okay, hello grade 12s. We're looking at 2.5. We kind of glossed over this lesson previously because actually we are going to use some old factoring techniques to kind of go for it. And we'll be graphing things from some sort of non-factored form and using old or past graphing techniques, factoring techniques to help us graph. Because we're comfortable graphing from standard form. So if I were to just look at the final form of this, I would know I have x-intercepts at 0, at -2, at +1, and -1, all order 1, and have a look. That's exactly where we find them. Our goal today is to have a look at how do we start off with standard form equations or something not fully factored and eventually get them into factored form. So we have different strategies. The one we always start off with is common factor. So looking for something, a factor we can divide all our terms by. We also know factor by grouping, creating that artificial line down the middle. Asking what's common between the first grouping pair and what's common between the second grouping pair. And from here, sometimes we may also have difference in squares. Long story short, once we use our old factoring techniques, like any of these quadratic techniques here, we get the x-intercepts from the factored form. We know the overall degree is degree 4 with a positive leading coefficient, so we can tell n behavior. We can also approximate turning points here, and then go from there. Okay, so let's just jump into it. Example number 1. We always start off with the common factoring, so let's have a quick look. And yep, this is definitely common factorable. We have an x squared common everywhere, giving us x squared minus 5x and plus 6. Looking for two things to add to a -5 and multiply to a positive 6. I think I got it. And we get the following the following factored form. And each of these tell us a story. X equals to 0 is order 2. Just mind you that when we draw this one, we want to draw it as a turning point. The other ones are quote-unquote regular x-intercepts 2 and 3. Located at 2 and located at 3. The overall degree of this thing is a degree 4, and it's a positive leading coefficient, so positive infinity and positive infinity are n behaviors. Let's give it a draw. Do I want to? Yeah, I gotta. I'm also gonna get the the approximate turning points. I was just feeling sort of lazy for a second there. I'm like, no, gotta do it. Okay, so they are located at 1, convenient, and also at 2.5, less convenient, but let's go for each. So if we plug in a 1 here, 1 plus 6, 7, take away 5 is a positive 2. We're getting a positive 2 there, and for 2.5, I will have to consult a calculator for this one. So that's 0.5 on the insides there, and 2.5 squared multiplied by 0.25, negative 1.5, negative 1.56. Okay, all right, there we go. So let's put them down. Positive 2 over here and a negative 1.5-ish. Okay, and we're going to get the following graph, something like the following. Remembering x, that's a turning point at 0, order 2, 0 there. Something like the following. Yeah, pretty good, pretty good. Okay, cool. That's our first one down. The next one over here. Ooh, have a notice. Look at the pattern in the powers. X to the power 4 and x squared. You can make a dummy or change of variables here, introduce a new variable. So let's call this now f of w, where w is equal to x squared. So this becomes 2w squared minus 40w plus 128. And it temporarily makes the variables look a little bit nicer, a little bit more quadratic. Common factor out 2, we're going to get 2w squared minus 20 and plus w and plus 64. Do I have any hints here? Yes, I got it. Okay. The two factors are w minus 4 and w minus 16. More interesting still, we only temporarily use this w, so let's insert our x squared back in for w. So we get x squared minus 4 and x squared minus 16, and hopefully you guessed it, both of these are difference of squares, so we can operate on that further still. Okay, so finally giving us 2 x plus 2, x minus 2 from the first difference of squares, and from the second difference of squares, something similar, x plus 4 and a x minus a 4. Okay, and oh man, we got lots and lots of x-intercepts. It's 4, 2, and 2 and 4. Okay, our turning points are located at f of 0 and f of 3. Lucky for us, because of symmetry, this will be also equal to f of negative 3, which is the other turning point. Okay, so the only one to calculate will be this one here. This one here is just 128 when you sub in 0. F of 3 is equal to, I have no clue. So let me just consult the calculator here. Here we go. Okay, so 2 times 3 to the power of 4 is 81. Plus, no, take away 40 times 3 squared, which is 9. And then add 128, giving us negative 70. All right, so negative 70 on the 3's, so about yay and yay, and 0 being, yeah, okay, cool. And behavior is degree 4, positive leading coefficient, so positive infinity, here we go. Oosh. Okay, gotta try to actually hit them. Okay, like the following. Beautiful. And a big W for Mr. D. All right. Cool. 2 more to go. Just breaking out those old factoring techniques here. 4 terms can be common factor? No, because of this 9. So we're just going to chop it in half. Common factor or factor by grouping each of those parts. First grouping here allows me to take a 4x squared out, leaving me on the inside with x take away 4. And the second grouping, I'll take out a negative 9, giving me an x minus 4, very promising, which is equal to x minus 4 and 4x squared minus 9. Ooh, look at that. Hopefully you caught it. It's difference of squares, giving me 2x minus 3 and a 2x plus 3. Okay, oh no. Okay, this one's going to be, oh no. All right, our x-intercepts are positive 4, 1.5, negative 1.5, and positive 1.5. Oh my goodness. Well, one of the turning points is nice, it's 0. The other one, not so nice, halfway between these two. Okay, we'll do it. F of 0 is equal to 36. Okay, how convenient. Almost 40. Okay. The other turning point is halfway between 1.5 and 4. Divide that by 2. That's equal to 5.5 divided by 2, which is equal to 2.75. Okay. Well, not fun, but you can do it. Grab a calculator. What is that equal to? Okay, so then we have 4 times 2.75 squared, no, to the power of 3. Let me fix that to the power of, oh, check it up. 2.75 to the exponent of 3, and then take away 16 times 2.75 squared, and take away one more time, 9 times 2.75, and then add 36, giving me decimal negative 26.5. Okay, so negative 26.5 is about here. All right, let's analyze the end behavior. This thing is degree 3, so odd with a positive leading coefficient. So we're looking at the bottom left to top right, something like the following. Here we go. Miss everything. Okay. Let me try this again. All right. Beautiful. be full. Okay, great. It'll work. It'll do. It'll do. Okay. Next one here. Oh, okay. Something squared. Take away something squared. You guessed it. This thing is a difference of squares. So here we go. So I'll do the first thing, and I'll add the second term inside, and then I'll do the second thing, which is x. Well, lucky for us, this is just a quadratic. Minus 2, and then take away the insides, 2x plus 1. Let's have a look what happens here. That gives us a 3x plus 1 and a negative x. Ooh, okay, something's happening here. Negative x and a minus 1 on the inside. Okay, we are not allowed to have this. We have to take the negative out. So we're going to do the following thing. We'll take out a negative, and that becomes an x plus 1 instead. So we divide both these by negative 1, allows us to factor out a negative term in front of one of the brackets. We'll keep it at the very front. And the other one stayed the same. 3x plus 1. This x-intercept is located at negative 1/3. Put it down, so just a little bit to the left. Here we go. And the other one is located at x equals to positive 1. Just kidding, negative 1. Oh my goodness, okay. And you know what? Shoot, yeah, we gotta do it. It's a parabola opening up, down, sorry. Ooh, okay, so I should have wrote that down. Degree 2, it's squared axis here, and it's a negative leading coefficient. Hopefully you spotted that, okay, something was off with this bracket. Common factor that out. Truly see that it's a negative leading coefficient. All right, where is that turning point located? Halfway between these two, so negative 1, take away 1/3 divided by 2, which is equal to 4 negative 2/3. Okay, that's not that bad. And we have to sub that in, which is a little annoying, but let's do it. So we get positive 1/3 times negative 1/3. No. Positive 1/3 here. And then multiply this 2 negative times negative 1, giving us a positive 1/3 here as well. Okay, odd, very odd. Double checking, yeah, okay, it's a really small one. Okay, there we go. Giving us a parabola like the following. Ooh. Opening down. Yeah. All right, one more to go. Here we're looking at, we can common factor a bunch of things actually. So let's look at what's common. We can take out a 5, and both of the terms have an x minus 3 squared. Okay, let's see what's left over. And the first one, we took out the 5, x is left over. We took out 2 factors of x minus 3, leaving us with 1 factor of x minus 3 inside. And plus, took out the 5 from the 10, giving us a 2. And we took out the x minus 3 squared term there. Okay, let's continue. We have 5 here. We have x minus 3 squared. And in here, let's pop open these brackets. X squared minus 3x plus 2. We can factor that, giving us finally, this one's not so bad. This one's kind of nice, actually. X minus 1 and x minus 2 with the x-intercepts equal to 3, 1, and 2. Oh, that's actually really nice. Okay, all right. Plug it in. 3, 1, 2. Approximate turning points, f of 1.5 and f of 2.5. Plug it in. Yeah, just plug it in. Okay. So 1.5, so it's 5 times 1.5 times 0.5 times 0.5. I'm getting about, it is a positive 1.88, so almost at 2, just shy, and 2.5 this time. So we're looking at 5 times 0.5 times 1.5 times 0. Oops. Also the same thing, but a negative this time, negative 1.8. just over there. And just fine. Okay. Oh yeah, I forgot something. Ooh. Also forgot something. This thing over here is degree 2. Not degree 2, sorry, order 2, meaning turning point on that one. Order 2. Okay, so just remember to do a turning point there. And let's have a look. We have, actually something not so nice here. We have, oh, I just got my signs wrong. That should be positive, that should be negative, so it's just vice versa. So negative here, positive here. Positive and negative, okay. And we'll get the following end behavior. We have this overall power is power of 4. Let's just double check. So this is x squared here. There's an x here. There's an x here overall, x to the 4 with a positive leading coefficient. So positive infinity, positive infinity. Let's have a look. We get the following. Beautiful. Okay, that's it for 2.5. Check out the homework.